Okay, so in these ones, the loop's not moving, but the magnetic field's either increasing or decreasing, right? So in this case, we're losing, and B is decreasing, right? So we are losing flux out of the page, and so we create flux out of the page, right? So that's anti-clockwise. In this guy here, we are gaining, because the magnetic field is increasing, right? So we are gaining flux into the page. And so if we gain flux, we always oppose the flux, right? And so we're going to create flux out of the page. You always oppose a gain and you replace a loss, okay? All right, next one. And then these next ones, these are my favorite, right? Okay, we're opposing the motion of the magnet, okay? So here the magnet's moving away, and this is a coil of wire. And to make that magnet not move away, we would create a north pole on this side and a south pole on that side, but it's the north pole on this side that counts, right? So to create a north pole on this side, the current would go, as seen from the left side, it would go anti-clockwise, right? That would be a north pole on that side. So it would go, therefore, up the front of the coil to create a north pole, to prevent the magnet from going away, right? Really what's going on is that the work that the magnet does turns into electrical energy is what's going on. Okay, now in this case, you've got a south pole approaching. And boy, you don't like that. You don't want that south pole coming into your, territory, right? And so what you do is you oppose it by making a south pole that faces it, right? And so the current would go down the front of the coil, right? And therefore the south pole would be on this side, north pole would be on the other side, but that's not important. We just want to oppose that motion, right? All right. Wow, just jumped. Wonder if that's the next line. I'm just going to do it whether it is or not. All right. Okay, so now we've got a magnetic field changing. So here we've got a magnetic field increasing. That means we're gaining flux out of the page. If you gain flux out of the page, the current's going to flow in such a way as to create flux into the page. It's going to oppose that, so it's clockwise. Okay. In the next one here, magnetic field's increasing. So we are gaining flux into the page. We oppose that by creating flux out of the page. Okay. And then in this guy here, we don't want that north pole to approach. And so the way to prevent a north pole from moving in, by the way, okay, is to create a north pole on that side. Okay, so this thing's going to act like a little magnet, and because this is a coil right here. And so the current needs to flow up the front of the coil, okay, to make a north pole in that direction. That's why that's the right answer right there. Okay? And then here, this guy here, we don't want that north pole to move away. We always oppose the motion of this magnet, right? Okay, so to oppose the motion of that magnet, we want to create a south pole on this side, right? So therefore, the current's going to flow up the front to create a south pole on this side to attract that north pole and make it want to come back, right? Just jumps. It's very jumpy. I'm on like print preview here with it all zoomed in. Okay, let's do one more row and I think you're good. Okay, so here we have magnetic field. Those X's are magnetic field. It's into the page, right? And we're getting more into the page. We're gaining flux into the page. If you gain flux into the page, the reaction is to create flux out of the page. So that's why it's anti-clockwise. That's why that's the right answer. Here we are decreasing the magnetic field. So therefore we're losing flux out of the page. If you lose flux out of the page, what do? Well, you replace it. So in this case, we're going to go anti-clockwise to replace that flux. Remember, you got a 50-50 chance. So if you start making mistakes, always make an even number of mistakes. All right, here we go. Now, we don't want the magnet to move away, right? And so to prevent that magnet from moving away, we're going to create a north pole on this side. To do that, the current has to flow up the front of the coil, down the back side of the coil, okay, to create a north pole on that side. I'm using the north pole rule here. Here I've got a south pole leaving. I don't want that south pole to leave. I don't want it to leave. Okay, so to prevent it from leaving, I'm going to create a north pole on this side. Okay, and to do that, I've got to make the current go so hard. It's got to go down the front of the coil, right? Okay, there you go.